Hi, this video is to help you understand and check your answers for the study guide 1A, lab safety and procedures. Okay, so you were supposed to go through and read the safety contract. Remember right here, if you click on the safety contract, boom, and you have then the contract come up, you are required to follow these directions and follow these rules whenever you are doing a laboratory experience inside of chemistry. Chemistry can be a very dangerous class if you're not paying attention to what you're doing. Now, most of these rules are fairly simple and straightforward, but I do need you to please make sure that you sign this by filling it in and sending me a copy of it, okay? I need to have a copy of it online in order to let you guys actually do labs in the class, all right? So please make sure you do that. Now, as far as the answers that go along with it, first question is, what should you yell out if you or a lab partner gets hurt in the lab area? Instead of saying, Mr. Price, just say something like code 1, or that's what I would prefer, so that I know that there is something very serious going on, okay? Instead of you just waiting to ask a question about some homework or whatever. Procedures for acid spills. Now, if you spill a small amount of acid, no problem. You basically dilute it with some water and wipe it up with a paper towel. However, if you spill a large amount of acid, then you will need to apply some acid. You need to supply a weak acid onto it. And I have bottles of those in my lab station in the fume hood, okay? But basically you want to apply baking soda, all right? Number 3, what is the fume hood used for? Primarily, it is used for working with volatile substances or vapors. Step 4, question 4, when should you read the experiment for the first time? You need to read it for the first time before you enter the lab area. That way you're ready for it, you know what to expect, and you don't make any mistakes that might be costly or dangerous. All right? Now, 5 rules for dressing appropriately for a lab. Rule number 1, whenever you're in the lab area, you have to wear goggles. And rule number 2, you got to wear lab aprons. All right? I'll demonstrate later on in the video how to do those. You also need to wear closed-toed shoes when you're in the lab area. Anything that covers the top of your feet would be acceptable. You please avoid wearing any loose jewelry or clothing that when you're moving around, you might knock something over in the lab area. And if you have long hair, anything that is shoulder length or longer, you have to tie it back in a tight ponytail in the top back of your head. You want to make sure all your hair stays behind your head throughout the lab. I don't want anybody catching themselves on fire, okay? For a burn, you basically take and flush with cool water and call your teacher, all right? And then we have to see if there's going to be additional first aid required. Don't put ice on it, all right? And don't do basically just cool water. Run it underneath the faucet. Let the water take all the heat away, and that'll make it feel better and do less damage. But you want to make sure you do it right away, because you can get a burn and it can keep on doing damage even if you're no longer touching the hot substance, all right? Should you ever do anything that is not part of an approved experimental procedure? No, all right? Definitely don't. Only do what is required for the lab. Don't start doing any extracurricular experiments, as it were, without permission from me, all right? Next question, what 2 pieces of protective equipment must be worn at all times in the lab area? Goggles and aprons. No matter what, if we're dealing with any type of chemical, glassware, or fire, you got to be wearing goggles and aprons in the library. Those are the law. I mean, those are the rules by the district, okay? To whom should you immediately report all accidents, injuries, and close calls? Me. I need to know about these things, okay? If you break a piece of equipment, I need to know about it. Don't try to hide it simply because it will become dangerous if somebody else in a different class period tries to use that same piece of equipment. Just fess up, let me know about it so I can replace it and make sure everyone stays safe. All right. Same thing if you burn yourself, or even if it's just a close call, I want to know if there's an unsafe situation that I can change so that nobody else has a chance of getting hurt. All right. Next question. Should you ever return used reagents to reagent bottles? Why or why not? No. If you return anything that's unused to a reagent bottle, you could accidentally be adding additional chemicals to that bottle, and it might therefore contaminate the reactants or the reagents. Next question. Where should all solid waste material go? Into the trash can, not down the sink, not left on the tabletop, but in a trash can. They're situated throughout the classroom. Make sure that if it's a paper towel, it goes in a trash can. If it's just paper, then it can go into the recycling bin. But paper towels are not allowed to go inside the recycling bin. Definitely don't sink them down the sink. A lot of times, if there is like matches or things like that, I will have a beaker out on the tabletop for you to use as a trash receptacle, okay? Please don't put anything down the sink. There's no garbage disposals or anything like that. It'll just clog up the sink, all right? Next question is, what is the first aid procedure for severe bleeding? Then what you're supposed to do is get a paper towel, wet it a little bit, and apply direct pressure to the bleeding. If you're hurting your arm, for example, you want to put it right on there, apply pressure, contact me, all right, and we'll see how bad it is and see if you need anything additional. All right. For fire, first aid procedure is you need to remove the oxygen from the fire. Okay. If there's a fire on a tabletop, sprinkling like baking soda or putting the fire blanket on top of it is a good way to go. To not add water. All right. A lot of times these fires are alcohol-based fires. If you add water to it, it'll just spread it, okay, and cause the fire to get actually worse. So you want to remove the oxygen. If it's a larger fire, then we can use the fire extinguisher in order to do that. That will replace the oxygen with carbon dioxide and will cool the temperature down, thus putting out the fire. All right. What is the first? Remember, by the way, if your clothing is on fire, then you need to use the fire blanket, which I'll explain how to use a little later on. What about base spills? Those, instead of putting a weak base on those, you put a weak acid on those. Otherwise, it's the same that you do for an acid spill. And I'll explain a little bit more about that later on. And then finally, what is the first aid procedure for chemical spilling on your skin or in your eyes? Basically, if it gets on your skin, you need to put it under this faucet and flush it with water. If it is a part of your body that is not able to go underneath the faucet, you spill it over a major part of your body, then you will need to use the safety shower, which I'll explain how to use in just a bit. If you get stuff in your eyes, then you need to use the eye wash station. Again, I'll explain how to use that in just a bit as well. This video is to help you understand where the various safety features in room 1150 are, okay? And there's a map that you're going to have to be labeling where these things are on your study guide or worksheet. And just to orientate you, this right here is the fume hood. Now, the fume hood is basically where I can mix noxious chemicals and all the dangerous fumes and so forth get carried up. It's kind of like a glorified ventilator above your stove. And if you're not going to be using it in this class, but if you ever see it in college or whatever, basically the way it works is you got a safety screen that can protect you in case there's any type of explosion or anything like that. You have a fan that sucks the air up and out of the building, and there's even a light to help you out, and we have gas and all this sort of stuff. And basically you are to mix the chemicals inside there. And that's how I mix them. This is where I mix chemicals for when you guys are doing various labs. Now, right next to the fume hood are two of the most important safety features, and those are the eye wash station and the safety shower, okay? Now, first of all, the eye wash station, this is designed for whenever you get something, a foreign particle or a chemical in your eyes. Now, of course, if you're wearing your goggles, that should never happen, but mistakes, people don't always have goggles over their eyes, and things like that could happen. Now, basically what you do is if you get something in your eye, you know, first of all, alert me, and then I will tell you to go over to the eye wash station. You basically come down, you put your face into it, and you slam this down, and a huge amount of water will start coming up at angles into your eyes. And because of our blink reflex, you want to make sure you take your eyes and pry them open. It's not going to be pleasant, but it's much better than going blind. And I will tell you when to stop, but basically you need to do that sometimes as long as 15 minutes. Yes, it sucks. Yes, it's not fun, but again, it's better than the alternative, okay? Now, here, this is a safety shower. Now, basically, this is if you spill huge amounts of water, huge amounts of chemical all over you. You're supposed to have your lab apron on, and that will help prevent any problems, but just in case, if you get it on your clothing and it's acidic or basic or any type of caustic chemical, you need to make sure you come on over here, and if it's over a large part of your body, you come here right underneath it, yank down on this, large amounts of cold water will come down on top of you. At the same time, you need to take off the article of clothing that has been saturated, okay? Basically, I know modesty and all that, but again, if it's something like a strong acid and it's eating away through your clothing, you need to get it off. You do not use this if you are on fire. Never put water onto fire in a lab area, okay? There's other ways of dealing with it. Now, over here in the corner, we also have where two of the other safety features are to be found. You have your goggle cabinet, all right, and you have the lab aprons. Now, the goggle cabinet is designed to sterilize the goggles with a very powerful UV light. And at the beginning of your lab session, I will have this open. You have the goggles in there. You take it and put them on, and the aprons are here. Now, when you put on the goggles go on over your eyes. If you have glasses, you need to put them on over the glasses. If they are too loose, there are knots that you can try to tie in the back or whatever, or there's some of them that you can actually still adjust using the straps. But you have the goggles on, must be over your eyes at all times when you're in the lab area. Not up here, not down here, but over the actual eyes. It's what they're designed for. And for the lab aprons, you want to make sure that you have the white side towards you. You put this on over your neck. Again, you can adjust it up or down. You can tie a knot. And then you take the straps and make sure you tie them behind your back. If you need help, your lab partner or I would be happy to help you do that, okay? But you want to make sure that you have this. This is both flame retardant and spill proof. So if you spill anything on a counter, it will hit this, okay, and you should be fine. You also need to, if we ever are doing a lab that involves fire and or caustic chemicals, you also need to make sure you wear shoes that cover the top of your feet, all right? No sandals, no flats, anything like that. If you can see skin on the top of your feet, that is not appropriate. Now, you can, ideally, so those are not appropriate, okay? Ideally, you want to have like a piece of leather over it, but at the very least, canvas will be acceptable, okay? Now, the other pieces of equipment that you need to know where they are is over here. This is where our fire extinguisher is. Now, the fire extinguisher is fully charged. The fire marshal comes in, checks it every year. It's all set and ready to go. If you need to get at it, okay, you simply pull it really hard. It'll break the lock, but you will be able to get at it. And then you take it, you take out the pin, you aim it down low towards where the fire is, And you use that whenever there's a fire in the classroom. Not when it's on somebody, but in the classroom. It basically blows very cold CO2 and replaces the oxygen with CO2 and lowers the temperature, and that's what puts out the fire. Now, this is by the door that you guys come in. Now, notice that this is the back of the classroom, all right? It's behind you guys. The front of the classroom is over there where I'm going to be standing. So in case there's a test question that says, where is the fire extinguisher? You're going to say it is in the back of the classroom by the front door, okay? And then the last piece of safety equipment that you guys will need to be aware of is right here. Now this is the fire blanket. Now the fire blanket is used for when somebody is on fire, okay? Now ideally, obviously, if you catch on fire, your clothing, your hair, you need to stop, drop, and roll. And while you're doing that, hopefully someone will help you out by smothering the fire, okay? That's what this is for. Basically, if you see somebody that is on fire, you need to remove the oxygen from it. And this is your chance to being a big hero. Basically, you run back over here, you flip this, all right? When you flip this, the bottom will fall out, actually, and out will come a blanket, all right? Now, you take the blanket, you unfurl it, and then you go and you jump on the person with the blanket between you and the fire, all right? And you smother the fire, not the person, but you smother the fire out and so forth. This is totally fireproof and insulated. It will protect you from the fire and it will help put out the fire, okay? So that's what is done. If someone is on fire, you use a safety blanket, all right, the fire blanket. Now the last thing Now, for acid and base spills, okay, these are different than just a normal chemical spill. If we are dealing with any type of acid and there's a spill on the desk or even on you, but primarily on the desk is where it usually happens, if it is a small spill, then you can simply wipe it up and you're good and then wash the area down with water. If it's a large spill though, we need to neutralize it, okay? If you have an acid, you need to put a base on it, a weak base. If it is a base, you need to put a weak acid. Now, I already have in the classroom here in the fume hood some containers that contain what you need to put on. For example, this right here says for acid burns. This contains a weak base. It actually is baking soda water, okay? And you just go and you sprinkle it all over wherever the spill is, and it'll neutralize it. Okay, and it'll be a kind of a cool bubbling reaction too. It's kind of cool. If there is a base spill, like sodium hydroxide or something, then you want to put something like this. This is a weak acid. All right. Now this happens to be boric acid. It's a weak acid that won't hurt you at all. And if you put it on, it'll neutralize it, and you'll be fine. Now, if you're at home, this is a good thing to remember as well, because we deal with pretty nasty acids and bases in our home sometimes. For example, if you have a car battery, if you have to take out a car battery perhaps to charge it or something like that, that is filled with sulfuric acid. And if you drop it or if it cracks and you spill some on you, it's all liquid, you can cause some serious burns. If that happens, then you want to get some baking soda. Just get some baking soda, sprinkle it over wherever the spill is, and then you can put some water on it and do that several times and you should be fine, okay? If you get a base burn, and we use bases a lot in our homes, one of the prime examples is like Drano or Liquid Plumber, something that you put down in the sink in order to get rid of clogs. That is a very strong base, and it's designed to eat through organic material, all right? While it's safe for the sink, it's designed to eat through, bits of meat and hair and stuff like that. Well, we're organic material, and if you spill some on yourself, it will start to eat through you. So if that happens, you want to neutralize it at home with usually vinegar, okay? Vinegar is something that almost everybody has in their homes. It could be red wine vinegar, rice vinegar, doesn't matter. Vinegar will neutralize it, okay? Thank you very much. Hi, so now I want to go over the answers for the remainder of the study guide. This is talking about the chemistry laboratory procedures, okay? Question 17, which part of the lab burner should you never touch? Well, other than the flame, when it's on, you never want to touch the brass tip. This is the only part that will actually get hot enough to burn you. Everything else, the barrel, the base, everything else you can touch while it's on, and you'll be just fine, okay? Next question, which part of the burner controls the temperature? That's the air vents, all right? The more air that comes in, the hotter the temperature will be. So the more open they are, all right, the hotter the flame. When you twist it and you close it at all, you're restricting the airflow and you're decreasing the temperature of the flame. Most of the time, we are going to be having it all the way open so that you cannot see the threads through the window. That's at full blast, and that's how we're going to use it most of the time. The next question is, which part of the burner controls the height of the flame? That is the gas adjustment valve here on the bottom. Again, it's a screw that screws up into the base. And as it tightens, okay, going in this direction, as it tightens, it cuts off the gas and it lowers the height of the flame. More gas, the higher; less gas, the lower the height. All right. Question 20, how are the air ports opened and closed? Again, that's by twisting the entire barrel. All right. Question 21, should the air ports be open or closed when you light the burner? You always want those all the way closed when you light the burner. That way it's easier to light, okay? You don't have to tighten it, but you definitely want it all the way closed. Next question is, how is a smooth line different from connecting the dots on a graph? Which one should you do? Well, let's say you have data points here. One thing I do not want you to do, I do not want you to go and connect the dots. This, to a scientist, tells me absolutely nothing. What I'd rather you do is try to draw, if it looks like a straight line, use a ruler. Otherwise, it might be a smooth curve, but you want to draw basically the average line between them. So looking at this, it looks like probably something along these lines, as it were. All right, a nice, smooth, straight line or curve that goes through the average of the dots. This way we can look for, and it's easier to identify, the trends, okay? So that's how you should do all graphs in science. Never connect the dots. Number 23, what two types of glassware should be used to measure liquid volumes accurately? First of all, pipettes are good, okay? They're basically like a little dropper. But also graduated cylinders. This is what we're going to be using most often, all right? Graduated cylinders. Even though beakers have graduations on them, these are very inaccurate, and you never should use them whenever accuracy is required. So you want to use graduated cylinders for that. Number 24, what is a meniscus and how is it used to measure volume? Well, when you fill up water or any other water-based solution into a graduated cylinder, at the top, because of the adhesion water has for the surface or sides of the glass, it will creep up the sides and form a bowl-shaped top. That's what a meniscus is. Now, when you look at it from the side, it'll look something like this, and it'll be a very thick top. Well, to be accurate, you want to measure it from the bottom of the meniscus, not the top. So an accurate measurement here, if this was up to 100, 99, 98, this would be 97 milliliters would be the measure. Now, for question number 25, describe how a liquid should be poured from a stoppered container in order to prevent contamination. Well, either stoppered or with a lid. You want to take the lid and put it between your fingers on the same hand that's holding the bottle. That way you can pour it, and that way the lid doesn't touch the tabletop, which might cause contamination, okay? Next question. What should be used to prevent splashing when pouring a liquid into an open container such as a beaker? So basically the answer is a glass stirring rod, okay? And the way it works is, let's say you have a liquid here, you take the glass stirring rod, you put it across the top so that it goes through the spout. Then, when you pour it, it will travel along, right, the spout, and you can better aim the direction of the stream, okay? And less chance of it spilling. Also, if you're decanting, this allows you a chance to prevent any of the solids that might be on the bottom from leaving. Because if you see them starting to go, you can pull it back and they'll be stuck to the stirring rod instead of getting into the other container. So that is how you do that. Number 27, with what pieces of equipment should you transfer a solid to a wide mouth container? Either a spatula, which is flat, or one of these, which is a scupula, all right, basically like a spoon, okay? But this is how you're going to be transferring solids. Number 28, describe how you should transfer a solid into a small mouth container, such as a test tube. For that, you want to use a piece of paper, a way paper, just a piece of scratch paper, and you simply fold it into half. You put the solid, like a salt or whatever, into it, and then that forms a funnel, and you can easily slide it into the test tube without it spilling all over. Next question, why do you think that you should never use a thermometer to mix chemicals? Because you might break the thermometer, okay? If you have a probe or whatever that is a thermometer, you don't want to use this because this is delicate, this is electronic, you don't want to be mixing things up with it. Always use a stir rod if you're going to be mixing chemicals, all right? Next, describe how you should mix chemicals in a test tube if you don't have a stopper. Well, so if you have a test tube and you have chemicals in there and you want something to dissolve or you want something to mix, you don't have a stopper, don't just put your thumb over it and shake, and you'll come back without a thumb sometimes, okay? Easiest way is simply to pinch the top of the test tube and flick it. Believe it or not, this works extremely well for mixing it, and it will prevent it from flying out and spilling all over, okay? And then number 31, why is weigh paper always used when measuring a mass of chemicals on a balance? Well, we don't want a chemical reaction to take place on the metal pan of the balance. So you always want to use weigh paper on top to protect the pan, okay? And prevent any unwanted chemical reactions. And then finally, what is rezeroing and how is it done? Rezeroing is when you want the readout on an electronic balance to read 0, even though it has, like, say, a piece of weigh paper on it, okay? And the way it's done is one of the buttons for most of the scales say 0, all right, or rezeroing, you just push it and then it goes to 0. Some of the older models have a tare button, T-A-R-E. That's the rezeroing button. You push that and it does the same thing. All right? So those are the answers for this study guide.